Welcome. So we're going to be taking a look at the June 2015. This is where we left off yesterday. Again, you can kind of do these on scrap paper. If we do have any graphs, you could pull out a template, a piece of graph paper. We're going to start by graphing the absolute value of x minus 3. Now, technically speaking, you could just throw your graph on the page and be done, right? A few people ask me, like, do you need to show a table? Is it like -1 if you don't? No. Obviously, teachers are going to recommend you show it, right? Kind of like how we say show your work, even though it might not always be required. So it's a good idea to make a table. Is it required? No, but do it. Now, with absolute value, we want to make sure that we make our table kind of like quadratics. We make it symmetrical, right? I don't want to end up just getting my graph that looks like this, right? For absolute value, this should create a V shape. So I want that vertex in the center. Can anyone tell me what number, and you could get this from typing into your calculator, knowing things about it, what number should go in the middle of my table? 3, yeah. It's going to be the number that creates a 0 within the absolute value part. In this case, it creates a 0 in general, but there might be a vertical translation that messes that up. So now we build around that. And again, you could type this into your calculator. Absolute value can be found by hitting math, scrolling over to, I believe it's number, like NUM, and then it's the first choice, ABS, and you should get the bars. You can type within it. If you ever have to type something outside of it, just make sure you hit the right key to exit the bars. And this way, whatever you add or subtract is happening outside. You could do this one without a calculator almost, though, because we're just taking the absolute value, which is pretty simple to do. Now you're going to go ahead and plot this 0, 3, 1, 2, 2, 1, 3, 0, da, 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 da. I get my V-shaped graph. It's important that we put arrows. That could be something you lose 1 for. Right? Put arrows on your graph. You don't need to label if it's not a system. The graph, that's perfect. Now, basically the explanation is what's the transformation in this problem? So what should the transformation be in this problem? Yeah, that's all you have to write. Keep it simple. It's a horizontal translation, 3 to the right. It shifted 3 to the right. It moved over, it slid, whatever word, verb you use doesn't really matter. 3 to the right. Perfect. Okay. Grace, you don't remember learning this. I hope you're not being sarcastic because we did this pretty recently. Okay. So this was absolute value, a pretty easy start to the written section in the grand scheme of graphs. Again, making the table, is it required? No, but you should still show it. Cool. All right.
Mr. Rice, can you just go back to the problem for 1 second?
Yep. What's up?
All right, that's all. I thought when I did it, I did something wrong. I didn't understand, but now I do.
Cool. Absolute value, we're always looking for the V shape. So if your graph looks weird, just be like, oh, I might have messed something up. Maybe I put -3 in the middle. All right. Alex is selling tickets to a school play. An adult ticket is $6.50. The student ticket is $4. He sells X adult tickets and 12 student tickets. Write a function, f of x, to represent how much money he collected. So this seems like a system, especially since we've been talking a lot about systems, but it's just an equation. They tell us to call it f of x, so guess what? We have to call it f of x. Right? Now, what should our rule be? What's the rule for this scenario? Do we have 2 variables? Are there 2 variables here? Seems like there are, but are there? No, there's only 1. Yeah, because they tell us how many student tickets. It's not unknown how many student tickets they sold. How many student tickets did they sell? 12. So they sold 12 of them. They're $4 each. I can clean this up in a moment, but for now, I'll just put that so we see where it's coming from. So there's no like unknown there. I know I made $48 from students. For the adults is where the variable comes into play. So what should I do to finish this one off? So this is just the student ticket portion. What should I do to finish this one off? What else is missing from this expression? Plus 6.5x. Excellent, Rachel. every adult ticket is going to add 650. I don't know how many adult tickets, so 6.5x. Now, if you want, you can clean this up. Maybe I like to usually put the variable first. Not something you have to do. You get full credit if you wrote what we wrote up top. But if you're just in the cleanup mode, you could do that. Perfectly fine if you left it as is up top. The chat doesn't show in the YouTube video. Oh, because I said your name, yeah. Cool. Kind of like yesterday, it's almost like, all right, like starts kind of easy. We saw yesterday they did get progressively harder. Not that it literally works like number 1 is the easiest and 24 is the hardest, but they tend to start off a little bit like, all right, not so bad. Questions with this one? If you came late, we said we are going to skip around a little bit. There's a written question that's no longer taught in Algebra 1, so obviously we're going to skip that. There's also like number 37 we're going to skip because we've done that exact example. You'll see what I mean. Okay. 27 is a system. We have a system. We just talked about this week. We have the amount of money John saves versus the amount of money that Sarah saves. We have f of x and g of x, and it wants to know after how many weeks will they have the same amount of money? Explain your answer. Now, technically speaking, what word do you not see here? That usually is like, oh, it's annoying. What word do we not see here? Algebraically. Good, Ethan. Like, so what does that tell me? I could use a calculator here, but we'll probably end up doing it algebraically, but always be on the lookout. Hey, they didn't technically say algebraically. All right, if they want to know where they'll have the same amount saved, that's basically implying, hey, where is f of x going to equal g of x? Right? So now I'm going to set the expressions equal to each other. And we have a quadratic on our hands because one of the equations had an x squared. So anytime I'm doing, and again, we just said we don't have to do it algebraically, but we'll still do it algebraically. Anytime I have a quadratic, what should my next move be? What should my next move be here? What should my next move be? No one's talking today. No, not like terms. Get it equal to 0. Good, get it equal to 0. So let's move everything to the right. I usually try to keep the squared term positive. Anytime we have a quadratic, get it set equal to 0. It's going to be minus 5x. 46 minus 60 is going to be negative 14. Now, because of the context of this problem, I know it's going to have rational answers, right? X is the number of weeks here. So I'm not assuming that this is going to be like 1 plus or minus radical 2 and I need quad formula, which tells me how can I solve this? Sometimes you can use the context of the problem. Yeah, this should be factorable, right? I mean, I'm expecting it to be a whole number being that the variable is weeks. And it obviously is factorable. What are the two bubbles if you do your sum product? What adds to negative 5 and multiplies to negative 14? We know it's a plus minus. Negative 7 and positive 2, good. Which means my answers are the opposite of that. We do our t-chart. My two answers should be 7 weeks and negative 2 weeks. So negative 2 is clearly going to be rejected. The answer to this is 7 weeks. And because we showed our process here, we don't have to do more of a verbal explanation. We have some proof to back it up. The explain your answer would be maybe if you use your calculator and you just wrote 7, you can kind of explain what you did. But our work kind of stands in that place. You could. I would not recommend it. You could, technically, you could always use CTS. There's not like an exception. It's just, this would not be a good time to. Same thing with quad formula. Why not factor it? Look how quick it was for us to factor it. So how would you, we kept saying you could do this on your calculator. How would you? Same thing, because you know it's a nice answer. Type f of x and g of x into y equals, go to your table and just look to see where are the y values the same. You'll notice when x is 7, they both have an output of, what is it, 95? Yeah, but you could just always divide it out, Kyle. Yeah, we showed our work, so we did explain it. The explain here is kind of taking the place of algebraically. So for people that just use the calculator, you just use guess and check, they are kind of forced to explain. If I see this work, I know that the person, I can follow what they did. Okay. Why do we reject -2? Weeks can't be negative. All right, we have a little polynomial question. These are nice, like some combining like terms, some stuff going on here. You've seen questions like this. Give you guys a minute to try it if you want to do it on your scrap paper before we do it together. Take a minute if you want to try this. Okay. So we know this problem is asking us to multiply, but it's not like PEMDAS like we're going to do that first, because we actually have to do the difference here first. So we're going to subtract, but being that we have parentheses around this, we actually have to distribute the negative. We have to distribute the negative. So this is going to be awesome in the YouTube video later. She's like playing with my cat. It turns into this. So we're distributing the negative there. Okay, we're going to combine like terms. We have 3x squared minus x squared. That's 2x squared. We have minus 2x and minus... What's wrong? -2 minus 3 is minus 5x. And then we have plus 5 and plus 2, which is plus 7. Okay? Okay. Now I'm going to take that answer and multiply it by 1/2 x squared, which again turns into like a distribution. Now with exponents, remember we add exponents. 1/2 times 2 is just 1, so x squared times x squared is x to the 4th. We have minus 5/2 x cubed, and we have 7/2 x squared. And this is our final answer. You could leave it. It's actually preferred when you write polynomials to have improper fractions. You don't need to write like 2.5. That looks a little weird. I guess you could do decimals, like -2.5 and 3.5 x squared. That's our final answer. Okay, questions there? Doing pretty good. Dylan invested $600 in a savings account that earns 1.6% interest. He made no deposits or withdrawals, so he's not touching it. That's not preferred. I would just, to be honest, that's how I do it. So he's not touching the money for 2 years. The interest is compounded annually. Finds the nearest cent, the balance after 2 years. So you need to know the general equation for this, which is this guy. This was exponential growth or decay, if you remember. So P stands for principal or starting amount. R stands for the rate given as a decimal. T stands for the time in years. And the plus or minus, plus would be if it's a growth problem. Minus would be if it's a decay problem, something going down. So this is going to be clearly growth. It says we're earning interest, right? You just use context like we're making money here. You don't get this equation, no. So you would need to know this. This is one of the ones you need to know. Not super complicated. Okay. So what's the initial amount here? What's P? You get quad formula, yeah. 600. And we said it's growth because we're earning interest. Now be careful. R is not 1.6. It's 1.6%, which is what as a decimal? Good, Mark. 0.016. So 1, just put a 1 in front basically, right? And to the T power. This is like what the equation looks like. And they wanted to know, hey, what is it after 2 years? So plug in a 2 for T. You could use y equals. You could use your home screen to the nearest cent. So we got to be precise. Let me pull out my calculator. You guys could do the same. 600 parentheses 1.016 close parentheses to the second power squared. We get $619.35, I believe. Someone double check me there. Okay. We make the percent into a decimal by dividing it by 100, or basically moving it 2 spots to the left. They said 2 years, so we plugged in a 2 for T. Questions with this one? We're good? All right. Ooh, all right. Inequality, let's just dive right into it, and then let's be careful. We don't want to stop. We've kind of seen these with inequalities. Like when we get our answer, let's analyze it then. So first thing that I'm going to do in this one is combine like terms. I have negative 3x and negative 5x. That's negative 8x. I'm going to move the 7 over through subtraction. So CLT first. Move the 7 over. You get 8. I'm going to divide by negative 8. Yeah. What mistake did we make here? We divided by negative 8. 8 divided by negative 8 is negative 1. What mistake do we make? You got to flip the sign. Flip your sign. So your answer is x is greater than negative 1, which isn't the answer, because now we want to analyze it. What's the smallest integer that makes this true? What's the smallest integer that makes this true? Kira's right. The answer is 0. 0 is an integer. Can't be negative 1 because we can't equal negative 1. The smallest integer that works is 0. Ethan said it too? Ooh, sorry, Ethan, I missed that. The answer is, how many friends? The answer is 0. Okay. Questions with that one? All right. If you're like, what the heck, Grace, you could say this for this question. You didn't learn this because they took this topic out of Algebra 1. So we're skipping this. Residual plots used to be a part of statistics, but they removed it about like 4 years ago. So don't worry about this question. It only came up on like 2 or 3 regions. All right, we did this in our quad word problem packet, that little thing we put together, but let's see, maybe we don't remember it exactly. A landscaper is creating a rectangular flower bed. I like to draw it the second you start naming shapes. Pretend that's a rectangle, where the width is half the length. Remember the trick I said when you're told these translations? Use the word that comes at the end as like your normal variable. So in this case, I'm going to call the length x. Now the other variable you try to relate to using x. So if the width is half of that, I'm going to call the width half x. Okay, whatever comes at the end of the sentence is your plain variable, and then you try to write the other variable in terms of that. I don't want to just use like x and y because then I have a system which I don't have. And the area is 34 feet. Now, how do we find area for a rectangle? Area is length times width, so I'm just going to multiply those two dimensions together. I get 34 equals 1/2. X times x is x squared. I get rid of the half by multiplying by 2. And now what do? Don't say quad formula. Don't say CTS. Don't say factoring. What do I do now? Yeah, take the square root. Square root property. Square root. Square root of 68 is about 8.246. I'm gonna leave it like that for now. What did the question want? The question wanted to know the width. So I get this wrong if I circle that. That was the length. The width, remember, was half of that. The width was the half x. This is where let statements can help you too, because you have like a little key up top. You're like, oh wait, width was the other one. The width here to the nearest tenth would be 4.1. 4.1 feet. 4.1 feet to the nearest tenth. Okay. 8.2, not the answer because that was the length. We don't even care what that is. Just 4.1 is all you need. Whatever comes at the end is your variable. Relate the other one to it. I created my equation using my area formula, length times width. X times x is x squared. Get rid of the half by times 2, square root. You don't need to do that, Studi, because you're going to be solving an equation anyway. You would do that if you had like all 3 of them or something. But you don't know the length anyway. Yeah, you don't know the length, so you're going to end up moving it. Yeah. Okay. Ooh. So that was it for the part 2s. We're getting into part 3 land. We have a 4-point question. I'll leave this up for a few minutes. I'll let you guys I'll take a little break of talking for a moment. Let's see what we come up with here. I'll say this, I'll leave you with this before I give you some time. The question just says, do you agree with Albert? Does the question say, hey, you have to solve it? So like Albert says these have the same answer. Do you agree with him? Obviously, we need some support. Go ahead. All right, so this one's a little unique. Does anyone have an answer yet? I'm not sure what to do. You're not crazy. This is like a weird one. It would almost be easier if they were just like, hey, solve this, right? He said, hey, these have the same answer. Do we agree? All right. So do we all notice that the first equation is the same, right? However, that's not enough info. I can't be like, oh, they have the same answer because half of it's the same. That doesn't really, tell us much. What I do notice is that the bottom equation is like basically one move away. So we might as well finish this. Can anyone tell me what y equals in the second system? So if you divide -51 by 8.5, can anyone tell me what y equals? You get 6. Okay. You get 6. Now, what we can do is, let's figure out what x equals. Basically, like we're solving ignore the first system for now. And again, there's a few ways of doing this one. This is just one of them. We're going to finish solving this second system, and then we're going to check to see if whatever this answer is works for this bottom equation. If it does, we know he was right. We don't even have to bother checking the top equation because that was an exact match. So that's the game plan here. So what do we get for x? So if you plug in a 6 for y, you get 54, 5y. 54 equals 48. And of course, they make it some decimals here. We get 8x equals -6. Or we get x equals -3/4, -6/8. All right, so that's the answer on the right. On the left, again, we don't need to check both equations because the top was already a match. We just have to check the bottom one. So I'm going to plug in a -3/4 for x. If it works, I know they have the same solutions. If it doesn't work, I know they don't. So that's plus 30. This is -9. We get 21 equals 21. So we could say, yes, we agree with Albert. As both systems have -3/4, 6 as a common solution. We showed some work. We're explaining our answer. We got the whole setup here. That's how I would probably do this question. You could probably do a few different things. You could have like solved the system on the left and see if the y value was the same. There's a few things you could do, but this is probably the fastest, I think. Wait, so if we plug y into the bottom equation, yep. Justify is usually more like math work, Rachel. Explain is usually more verbal. I don't get how you got 8x plus 54. We plugged in a 6. So we got y equals 6 because this was like basically solved for, right? And then in the top equation, just like if you were solving a system normally, you know, when you get one variable, you plug it in to find the other one. We plugged in a 6 for y. 9 times 6 is 54. How did you get the x value? That's the y value, Austin. The x value, I had to plug in the 6. So I took this, I plugged in the 6 here, and then I solved this kind of up top. I did this a little messy, but I got 54 and moved the 54 over. That's where I got the -3/4. Okay. Cool. So kind of a weird one. I remember this year, this question like threw people off. It probably would have been just easier for them to say solve the system because people just didn't know what to do. They were like, some people said yes because the top equation matches, which is obviously, it ends up being true, but it's not true. Okay. Ooh, I like this one. All right, I'll give you guys some time for this one. We have a piecewise. We talked about functions today in review. We have like a piecewise function that we're going to analyze and do some stuff with. Let's try this one out. Take a few minutes. We're going to skip 37. 37, spoiler alert, is like the field goal one. You guys might remember doing this one. The field goal, like, and it was a trick with yards and stuff. We did this exact question, so I don't find much point into doing it again. So we'll probably get all the part 3s done, and that will bring us to an end. All right, but I'll give you a minute or two to get set up or started with this one. Analyzing a piecewise function. You might even recognize this one. I think we saw this one. How many people are in here? 47. Wow. Okay. So it says determine the difference in dollars for someone who works 52 hours versus someone that works 38 hours. So let's figure out how much someone that works 52 hours makes, and let's figure out how much someone that works 38 hours makes. If you work 52 hours, with piecewise, with analyzing functions, you have to figure out which rule to plug into. 52 hours belongs to the bottom rule. That's where 52 is defined. So you would plug in a 52 there. That would become 12. That's minus 40. 15 times 12 is 180, plus 400 is 580, I believe. 38 belongs in a top rule. That's where 38 is defined. 38 is between 0 and 40. 38 is also very easy to find. You just make 10 bucks an hour. So that's 380. So what's the difference? If we stopped right here, we would get it wrong. What should our answer be for this question? Good. 200 bucks. Just subtract the two. Subtract. How many hours does someone have to work to make $445? So if you work 40 hours, you max out at 400 bucks, right? If you're like the most you can make in the top function is 400. So we know it has to be in the bottom function. If we want to do this algebraically, we could say, hey, take this bottom rule. And again, we're using the bottom one because that's maxed out. The top one is maxed out at 400. So where would the bottom rule be equal to 445? I mean, you could very easily just notice like, hey, this is $45 more than 400, but let's pretend that we don't. You could do this, move the 400 over, you get 45, divide by 15, you get 3. 43 hours is your answer for this next part. Just showing how to do it algebraically. Again, you could do it a few ways. You could be like, well, you could make 400 bucks working your normal 40-hour week, and then the remaining $45 would be like the $15 per hour, 3 of those. So 40 plus 3, 43 hours altogether. But I did it more of an algebraic approach. 43 hours. Okay. For 35. 35, we have our topic from yesterday, a system of inequalities. So what I want to do first is create a system of inequalities given that paragraph. Now, it doesn't say X and Y in the paragraph, but if you look down below, it kind of does. So we're going to use Y to represent computers. That's on the Y-axis. And X to represent printers. You kind of had to look ahead to the graphs before you started creating. So take a moment, create 2 inequalities, what we call a system, and then we'll get to the graphing part. Yep. Probably go a little bit later. We have one more problem after this, Kyle. We'll go until I run out of watermelon. I don't drink the juice. This is seedless. Seedless watermelon. You never had a seedless watermelon? Okay. Okay. So using X and Y. Using X and Y here, can someone give me an inequality that represents this situation? Can someone give me an inequality that represents this situation? Good. So X plus Y is less than or equal to 15. The key word there is maximum of 15 items. Okay, how about our next one? We're using X and Y, Grace, because we're gonna graph it in a moment. But yeah, good. 50x plus 2500. Wait. Yeah. No. 500 plus 500y is at least 2500, so greater than or equal to 2500. Now, what did we learn yesterday with graphing these? What's the best way of graphing these? Yeah, standard form. What are the two intercepts for the top inequality? They're just going to be 15. For those, you could just tell visually, because the other variable goes away. There's nothing to divide by. And the bottom one, we actually have to divide. We know this is solid, and we know this one is shaded below. Solid because it has the equal to, below because it's less than. For the second inequality, we have x and y intercepts. What's the x-intercept? So the x-intercept is going to be 50x and 2500. 2500 divided by 50 is going to be 2500 divided by 50. 50. The x-intercept is 50. For the y-intercept, pretend x isn't there, right? Because you're plugging in a 0, it goes away. You're left with 500y and 2500. What's your y-intercept going to be? Just 5. Just 5. This is also a solid line. And where's the second one shaded? What's up? Where's the second one shaded? Above. It says greater than. Okay, so let's see. It's kind of a weird scale. I got to be able to get up to 50, but also some low numbers here. I'll probably go by, I'll go every other one is 5, so kind of like 2.5, so it's not super spaced out. If I go by 5s, then my y-intercept is going to be like the first box. So let's try to space it out a little bit. Every other is 5 should work. Let's see. Yeah, that works. And let's cheat the system here. Oh, wait, that's not going to work. Oops. Okay, so my x and y intercept is 15 and 15 for the top one. Let's get that one over with. 2 points, solid line. Let's hold off with shading. We can see this is going to be pretty narrow to begin with. My second inequality, I'm going to do 50 and 5. The y-intercept is 5, also a solid line. You'll be given a little mini rule on the Regents. This one is shaded above. Okay, so the blue line was shaded above, the green line was shaded below. I could see the solution is going to be between them right here. There's a follow-up besides this, but what am I missing on my graphing portion? What am I missing on the graphing portion? Label, 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 label. Okay. Any questions with that before we look at the follow-up? My scale, I probably could have done a few things. I just tried to space it out so it wasn't too crammed. We probably could have done a few other things, but you can make your scales different as well. I kept the x and y the same here. Like I could have spaced out y a lot more if I really wanted to, but you can make them different. All right, determine a combination of printers and computers that would allow the store to reach their goal. Hey. Determine a combination of printers and computers that would allow the electronic store to reach their goal. Explain how you obtained your answer. So can anyone give me a possible combination? How many printers and how many computers? 10 computers and 5 printers. That's weird. You both had the same one. 5 and 10. Does that work? Yeah, 5, 10. I'll do it in red. Close. I think that works, right? 5 and 10 works. 5 and 5 works. Anything that's within there, they have to be whole numbers, obviously. 5 of each, 5 computers, 5 printers. And for reasoning, you just say they're both in the solution region, the shader region, whatever you want to call it. Solution set, shader region. Hey. Okay. 1, 3. Yeah, so you might think coordinates. That's why it's helpful to label your numbers there. There's a few options. Okay. All right, the last question we do, again, I'm skipping part 6 here, is that football one. You guys might remember doing this. This was in your quad packet. This was like, had a crazy number of points on it, and then the trick was like in yards. So we spent like 20 minutes doing that. All right. This one might be a little tough because we haven't reviewed this topic. We might be a little rusty with it. We're creating an exponential equation. This will be our last one. Okay. For the exponential equation, we have a table of values. We're going to write an exponential equation that models these data. That always looks weird. This data should be. I guess data is plural. These data. So an exponential equation is always going to look like this. Let's put this down first. We could do this with a calculator. There's an xreg feature. We'd have to type in all the values, and it will, just like linreg creates a line, it will create an exponential. So we could do that if you want to. The football one was 6 points. What we could do if we're doing this by hand is very easily just figure out what are they multiplying by and what is the initial value. That's what A and B stand for. So what they're multiplying by isn't glaringly obvious. Does anyone know what you're multiplying by to go from 120 to 180 to 270? Yeah, I'm getting a few different answers. It's, oh, yeah, it's 1.5. It's 3 halves, 1.5. If you're not sure what you're multiplying by, divide. If you don't know what 120 got multiplied by to give you 180, divide. So the common multiplier here is 1.5. I'm just going to call it 3 halves for argument's sake. 1.5 is fine. Now, the y-intercept, the initial value, which is A, is not 120. Not 120. Remember, the y-intercept occurs when the input is 0. Can anyone tell me how we could use 1.5 to figure out the y-intercept? Rachel says it's 80, and that's correct. Rachel, how'd you do that? Yeah, we could just kind of, almost like we've done this with sequences in the past a bunch, like working backwards. Like if you know the pattern is this going forwards, you can work backwards by dividing by that. So that equation should work, and you could check it. Type it into your calculator, y equals, and just verify you get that exact same table. You should. Questions with that? If you really don't like that, you could use L1 and L2, do an xreg, and you'll get the same answer. Cool? Oh, this one had a really weird one. I forgot about this one. Okay. Use this model to predict how many downloads the developer would expect in the 26th week, rounding to the nearest download. So how can we do that? If it doesn't say algebraically, Rachel, you could always, your reasoning could be like, I used my calculator, and just mention what you did. You don't have to say every button, like, oh, I did a xreg on my calculator. What are we doing for part 2? Plug in a 26 for x, yeah. Basically saying, hey, what is f of 26? Plug in a 26. You definitely need a calculator for this. You definitely can't do this by hand. We're going to do, if you already have it in y equals, if you want to look, or just in your home screen, plug in a 26 for x. 1.5 to the 26th power times 80. What do we get? To the nearest download, so the nearest whole number, we get 30, 30, 140, and that's like 0.19, so that many downloads. Downloads, abbreviate. 30, 30, 140. All right, and this is a very interesting final part. This is the last thing we'll do today, I promise, if you're like waiting to leave. It said, would it be reasonable to use this model to predict how many downloads happen past 1 year? Before you answer, I'll throw you back to your car or house project, because you had a similar question in that project, right? You kind of created a model for stuff like in the short term, but then think about what you noticed like later on down the line. What do we think? Is it reasonable to predict the number of downloads past 1 year? Kind of a weird question, because most people are like, yeah, you would just plug in 52 weeks, 53 weeks. The answer to this is actually no. It's not reasonable. And you might be like, who says I could plug in whatever I want? You have to kind of bring some common sense to this. A few things you can say. Oh, no, it's not reasonable. You could say the numbers would get too large to accurately model the data, right? And if you plug it in, let me get into my y equals to actually have some numbers here. It's exponential functions like kind of work in the short term, but this is going to get like way too large. I think if I remember correctly, it like gets larger than the population of Earth. So if you put this into y equals, I'm going to turn my table on S so I could just type in, hold on. Past 1 year, so like X, there's 52 weeks in a year, like 55, let's say. When X is 55, Y is, let me write down the number. So after 55 weeks, a little over a year, the output is 387.3550613. So this is like in January after a year. There's, what is this number even? 387 billion downloads. So that's what I mean. Like it's growing too rapidly. It works well in the short term, but the numbers get too large. That could be your reasoning. The numbers get too large to model the data past 1 year. Just like your car project, it was the opposite problem. Remember with the cars, like it said your car was worth a penny after 10 years, right? It's not accurate. Models only work in the short term because exponentially either growing so rapidly or declining so rapidly past that. A weird question to end on. I know people were thrown off by this, but hopefully that example showed you what I was talking about. Hey, it's like getting into the trillions pretty soon after a year, so it's not really accurate. I saw people, and they got credit for this, they're like, no, there's more downloads than people on Earth after a year, so like it doesn't make sense. It gets way too large. This app, yeah, the app's gonna crash. Rachel, yeah, your calculator says something with E. If you highlight it, it will show you what it is on the bottom. So like move the cursor over so it like highlights. Like what I'm looking at says 3.9 E to 11, E11, but if you put your cursor on it, it will show you on the bottom. For the middle part, we rounded down. It was like 0.1, so we rounded down. All right, guys, we're gonna call it quits there. Again, 37, I'm skipping because that was a question we'd previously done before. This was June 2015. We're concluding it. Over the weekend, I'll talk more about this in class tomorrow. We'll probably do a mock Regents with like you guys taking time to sit down and kind of trying to do it legit, and we'll grade it and take a look at it next week. Now, obviously, this isn't like, doesn't count for anything or something like that, but we'll use that as a benchmark to kind of see where you're sitting so far. Like, all right, I'm getting, you know, a few multiple choice wrong. I'm losing a few written points here or there. We'll try to do that over this weekend. All right, guys, everyone. Yeah, you would round normally for this. It said nearest download, so you would round mathematically. And Lucas, we figured out what we were multiplying by doing 180 divided by 120. It's an exponential function, so it's a times b to the x power. 1.5 or 3/2 is our base, and we found 80 by dividing. We did 120 divided by 1.5 to find 80. All right, guys. Everyone have a good day, and I will see you tomorrow.